Okay, so in this lesson, we'll be covering exercise 5F, which is all about expanding brackets. Our learning intentions to understand what it means to expand brackets, to be able to expand brackets using repeated terms or rectangle areas, and to be able to expand brackets using the distributive law. The very first thing that we're going to do is explore this topic using rectangle areas, and that's our very first thing here. So this is going to help us build our understanding. So let's read the question. It says, write two equivalent expressions for the area of each rectangle shown, only one of which includes brackets. So only one of our two expressions can include brackets. So we have to think of two equivalent expressions. All right, how are we going to do that? Equivalent expressions for the area of this thing. Well, as you can see, we have the area. It has a width of 2, and it has a length of, well, this right here. And as you can see, it's broken up into two parts, this 5 and this X section. So one way of finding the area of this thing is by treating them as two separate rectangles. So we could find the area of this section. Let's call that A1. Then we could find the area of this section. Let's call that A2. And then we could just add those together, and that will give us the area. All right, so to find the area of A1, how do we find the area of a rectangle? Well, it is simply width times length. We know the width is 2. We know the length is 5. 2 times 5 is 10. So we can put 10 here for A1. To find what the area for A2 is going to be, let's just rub some stuff out here and have a nice good look. We know that the width of it is going to be X, and the length of it here, well, this is going to be the same as this. So that means it's going to be 2. So it's going to be 2 times X. 2 times X. And we know that 2 times X is just 2X. So that means our answer is going to be 10 plus 2X. So just to reiterate, the way that we did that is we found this section, then we found this section, and that gave us the area of this rectangle. Now, the other way to find the area of this rectangle is, instead of treating it as two separate sections, is instead to treat it as one rectangle. So that means we take the width, which is 2, and we multiply it by the entire length. But the problem is that this length is made up of two sections. We have this 5 section and we have this X section. We want the entire section, so what's that going to be? Well, it's just going to simply be 5 plus X. 5 plus X will give us the entire section, the entire length. So that means it's going to be 2 times, now we're going to put it in brackets, 2 plus 5 plus X. And that's because we want to multiply the entire thing here by 2. If we didn't put brackets, let's say we didn't put brackets, what we would end up doing by the laws of BIDMAS is doing 2 times 5 first, but we don't want that. We first want to figure out what the length is going to be, and then times that whole thing by 2, because it's length times width. Now, we don't like putting in the multiplication sign, rather, we just don't put it in. We just write it like this. And that is going to be our answer. And these two things here are equivalent expressions, which means they equal each other. So 10 plus 2x is equal to 2 brackets 5 plus x. And later on, we'll be seeing exactly how these are related to each other. But let's keep on working here. All right, so we have to think of two equivalent expressions, which represents this rectangle here, the area of it. So 1, 2. The first way to do it is to say this is A1, this is A2, and then add those together. So to find A1 here, it's simply going to be 12 times A, which is just 12A. And then to find A2, it's going to be 12 times 3, which is 36. So that means our answer would be 12A plus 36. The other way to find the area of this thing is, instead of adding up the two separate sections, is to simply find the entire area. So we're just finding the entire thing this time at once. To do that, we would say it's 12 times the entire length. If this part is 3 and this part is A, 3 plus A is going to be the entire length. So we're going to go 12 multiplied by 3 times A. And we know that's the same, sorry, whoops, daisy. 12 multiplied by 3 plus A. And that's the same thing as this, 12, 3 plus a. Because remember, we don't like writing in those brackets, those multiplication signs. We don't like writing in those multiplication signs. Okay, and those two things are going to be equal to each other. And we're going to be seeing more about that later. Okay, let's keep on working. All right, so now we've got this one. And we're going to approach it the same way. We've got two ways of doing this. The first way of finding out the area is to deal with each individual section. And as you can see here, instead of having two sections, we instead have 4 sections. We have this, 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 this. Okay, how are we going to do this? Well, what if we just found this, which we'll call A1, then we'll find this, which we'll call A2, then we'll find this, which we'll call A3, and then this, which we'll call A4. And then we could just add all those together to find the total area. So no different to what we did up here. To find A1, it's going to be A times B, which is AB. To find A2 is going to be A times 2, which is 2A. To find A3, it's going to be 7 times B, which is 7B. And to find A4, it's going to be 7 times 2, which is 14. And just like that, we have found our answer. That is going to be the expression that represents the area of this rectangle. Now, the other way to figure out the area of this rectangle is to treat it as one whole, which means we're going to go this entire length multiplied by this entire width. Well, if this is 7 and this is A, then this width is going to be A plus 7. And if this is B and this is 2, then this width is going to be B plus 2. And we could put them in brackets. We're now going to multiply these together. So A plus 7 multiplied by B plus 2. Remember to include your brackets, and also remember, we don't like this multiplication sign. We much prefer just to write it like this. They're just right next to each other, and we know that they're being multiplied because that's just something in algebra that we do. Okay, perfect. Now, it's important that you know how to answer these types of questions in which you have 4 areas. But it's not going to be the main focus of the exercise. Rather, these things up here are going to be the main focus of the exercise, and specifically knowing how this is equivalent to this. So why is it that 10 plus 2x is equal to 2 brackets 5 plus x? And so down here, how is 12 plus a plus, how is 12a plus 36 equal to 12 brackets 3 plus a? How is this working? So let's now go through that. So we're still building up our understanding. This says, and let me get my highlighter out here, the expression 3a plus 2 can be written as a plus 2 plus a plus 2 plus a plus 2. Simplify this expression by collecting like terms. All right, so what exactly is this telling us? If we have 3a plus 2, 3a plus 2, we know that there is an invisible multiplication sign between the 3 and the brackets. So this is telling us we have 3 lots of a plus 2. So therefore, we could say that it's the same thing as a plus 2 plus a plus 2 plus a plus 2. We have 3 lots of a plus 2. There are 3 lots of them, and that's exactly what we're told here. Now, if we collect like terms, so that means a plus a plus a. Well, that's 3a. And then we collect all the constants. 2 plus 2 plus 2. Well, that's 6. So what we have just done is we have shown that 3a plus 2 is equal to 3a plus 6. That's what we've just shown. Let's go through another example. And we'll leave that one so we can still see it. This says, state to this in full without brackets and simplify the results. So here we have 2, 4a plus 2b. And remember, there's an invisible multiplication sign there, which is telling us that we have 2 lots of this right here. So that means we have 1 lot plus another lot. If we now gather like terms, we would say I have 4a and 4a. 4a plus 4a is 8a. And I have 2b plus 2b, which is 4b. So what we have just shown is that 4a plus 2b is equal to 8a plus 4b. That's what we've just shown. Now the question is there a quicker way of going from this to this, because it's a bit cumbersome writing out this repeated roots. And can you imagine if instead of 2 or 3 we had 8 out the front? It would take us a long time to write them all out. So is there a quicker way of figuring out this form, this equivalent expression of this? And there absolutely is. And maybe you've already seen it. And that is, what is the relationship between these numbers and these numbers? Well, hopefully you've seen I have two lots of 4a plus 2b. Well, that means I have 2 lots of 4a. I have 2 lots of 4a. So in other words, I have 2 times 4a, which is 8a. I also have 2 lots of 2b. Well, 2 times 2b is 4b. And so too up here, this is saying I have 3 lots of a. 3 times a is 3a. It's also saying I have 3 lots of 2. Well, 3 times 2 is 6. So what we're doing here is we're simply multiplying 3 by a and then 3 by 2. We are simply doing that. And that is what we're going to see now. So now we're going to get into a bit of theory, and we're going to talk about what this is called. This is called the distributive law. It reads, to eliminate brackets, you can use the distributive law, which states that, and as you can see here, it's saying a times b, a times c, in which we get ab plus ac. And over here, we have a times b, which is ab. And as you can see, we have a minus there. And if we have a minus there, we have a minus here. And a times c, which is ac. The process of removing brackets using the distributive law is called expansion. When expanding, every term inside the bracket must be multiplied by the term outside the bracket. So here's an example with just numbers. If I have 5 times 27, I could break up this 27 so that it's 20 plus 7. We've actually seen this before in previous units. So now I have 5 times 20, 5 times 7, 5 times 20 plus 5 times 7 is 100 plus 35, which is 135. This is the distributive law. All right. Let's go through some more examples here to really solidify this. So we're going to use the distributive law. It says, state the missing parts of the following calculation which use the distributive law. Don't forget to draw in the arrows to help you distribute. Okay, so let's start off with an example with just numbers. So here we have 3 times 21. We've previously done this. A really good way of mentally doing this is to break up this 21 into 20 plus 1. But when you do this, you have to remember it's 3 times 20, then 3 times 1. And that's what I mean when I say draw in the arrows. I want you to draw in these. So whenever you see something that requires you to expand brackets, it's really helpful if you do that. Because this is telling you we're going 3 times 20. So 3 times 20 plus 3 times 1. 3 times 1. 3 times 20 is 60. And 3 times 1 is 3, which means 60 plus 3 is 63. That is how it works. So let's now do an example with a pro numeral. Again, the first thing you're going to do is you're going to draw in those arrows. So a question might say expand. It will say expand this. And you would say, okay, well, that is going to be multiplied by that, and that is going to be multiplied by that. So it's going to be 7 times 2 plus 7 times a, 7 times a. 7 times 2 is 14, plus 7 times a is 7a. Let's go to the next one. So again, it would say expand this. It would say expand. So get used to that word expand. It's going to say 3 times 4x, 3 times negative t. So it's going to be 3 times 4x. I also want you to take note of the fact that before we move on, because we have a negative here, it means we have a negative there as well. That's very important. This will be t. So we're going to get 3 times 4x, which is 12x. Then I've got this minus, and then I've got 3 times t, which is 3t. And just like that, we have done that. So now we just have few last examples here that I want to go through. It says expand the following expressions. Expand the following expressions. So whenever you see that word expand, the first thing I want you to do is I want you to draw in those arrows, which is telling you to go 5 times x, which is 5x, plus 5 times 3, which is 15. And just like that, we have expanded. That is the answer. Nice and easy. Next, we come here. I'm going to have 8 times a, which is 8a, multiplied by 8 times 4, which is going to be 32. And it's important that because we have a subtraction sign here, we have a subtraction sign there as well. Let's now go through the next one. Here we have 3 times 5a and 3 times 2. 3 times 5a, well, that's going to be 15a. And 3 times 2, that's going to be 6. And just like that, we have answered the question. Let's now go on to the next one. Here we have 5a, so it's going to be 5a times that, then 5a times that. 5a times 3p, well, 5 times 3 is 15, and then I just put my pro numerals next to each other. Then I'm going to go 5a times 7q, 5 times 7 is 35, and then I'm going to have a and q. Now remember, because there's a minus there has to be a minus in between those two terms. That's really super duper important. All right, let's keep on going. Last two. Here I'm going to go this times this, then this times this. So this is going to be x times 2y, which is going to be 2xy, plus x times z is just xz. Last one. So remember, you draw in those arrows, which tells you 6m times 2k is 12mk, minus 6m times 3n is 18mn. And remember, because there's a subtraction there, there's a subtraction sign there as well. And just like that, we have finished. That is expansion. So in this lesson, what have we done? If we come back to our learning intentions, we hopefully understand what it means to expand brackets. We are able to expand brackets using repeated terms and rectangle areas. So this right here was using our rectangles. And then this one right here was using repeated terms. And then to be able to expand brackets using the distributive law. And that's what we saw in our last page there, using the distributive law to do it. Hopefully all this made sense, and I'll see you in the next lesson.